Hello friends, welcome back to the another lecture. I'm Abhishek Tyagi and you are watching me on Shiksha for Naukri. So today we are going to start our new topic for engineering student, or we are picking an important subject of engineering, civil engineering. I'm going to teach you today here a civil engineering subject, that is surveying. Okay, as mentioned on the board. So in surveying we are going to see labeling. What is labeling and what are the important concepts of labeling? This will help you guys to understand the basic of labeling, because in surveying the labeling is very much important to start any project. Okay, so you have to know what is labeling, what are the important terms which include in labeling, or what are the important concept to understand the labeling. So today's our topic of discussion is labeling. This lecture will help you guys to understand the engineering aspects of labeling. So stay tuned for the lecture, and without further waste of time we are going to start our lecture of surveying. Okay, so in surveying, before going into the labeling, I am explaining you some important terms which will help to understand the concept. Okay, so first of all, I am taking as vertical contour, or sorry, vertical control. Okay, so today we will see what is vertical control, then we will study what is datum or reference, then mean sea level, then we will study equipotential line, benchmarks, temporary benchmark, permanent benchmark, RLs. So these are the some terms. Before going into the labeling, we should know what this term means. Okay, so first look into vertical controls. Okay, so what is vertical control? Vertical control define the 2 points, first and second. It will explain the 2 point. First is to measure, okay, and second is to fix the desired height. First is to measure. What to measure? The elevation of any point. So we will establish it with the help of vertical control. Second is to fix the desired height of point. Now first of all we have to see through what these 2 points want to explain. Okay, in vertical control, what is the meaning of to measure the elevation of points? All right, and second is to fix the desired height. Here we are using the word height. Later on we will see some another word which is related to the surveying, that is known as RL. We will see it what is RL later on. All right, so first we have to understand what is vertical control. In vertical control, to measure the elevation of points, second to fix the desired height of points. For example, I want to explain these 2 points with example. Okay, suppose this is our reference point, and all right, now we have to measure. Suppose here we have a point capital A, so we want to measure the elevation of this point from your reference. So this is come under vertical controls. That means you are measuring the elevation of this point from some reference point. So this will come under vertical control of point 1 to measure the elevation of the points. Next is to fix the desired height. For example, there if you have a building near the ground and you want to fix a point, so how will you fix? You will fix with the help of some certain reference level. Suppose this is your reference level and this is another point which is on a building. So you want to fix the point, or you want to fix the height of this building, desired height. It can be any height. Suppose the height of building is h, from where? To the reference. So this line is taken as reference. What is reference? Or you can say in civil, this reference is known as datum. We will see through to the next point what is datum and what is reference. Okay, so by fixing the point of a height is done by vertical controls. Okay, so these are the two operations to understand what is vertical control. Okay, I hope these 2 points are clear. Suppose this is a ground and we have taken a point in this ground. So the height of any point in this ground is known as the elevation of this point, and this is done by vertical control in point number 1. Second is to fix the desired height of any point. Suppose we are going to construct any building project in nearby areas. So to fixing the height of a building or to fixing the height of any point on the building is done by vertical controls. Or you can understand it by to measuring the vertical height with respect to any reference in the ground is come under the vertical control. Okay, so move on to the next point. If you want to understand this point, to measure the elevation of the point, you can also say it as to determine the height of points. You can also say that to determine the height of points. You can also say it as, or to measure the elevation of the point. Second is to fix the desired height. These 2 points come under the category of vertical controls. Okay, so next we can see that what is datum and what is reference. Here I have mentioned a word datum, so we have to understand it. What is datum? So next we are taking as datum or reference. Okay, so in civil engineering the reference point is named as datum line. So what is datum line? Datum line is a point, or datum line is that line from which we are taking our vertical heights of any point in a field or vertical heights of any building. So we are measuring the height of a building, or we are establishing the point from a certain level, or that level is known as datum or a reference level. Okay, so here I have mentioned the datum as a straight line, but in practical, as you don't have this straight line in your field. So how will you establish the datum or reference in the field? This is the big question. So now we will see what is datum, or how to establish a datum or reference in the ground or in field. Okay, so for small distances there are now 2 conditions to establish a datum or reference. Suppose if my area of survey is small, or if my area of survey is very big. or very large. So these are the two conditions in which we have to establish or we have to determine our datum. So first let's see into the, if my area of survey is very small. For example, as I'm standing in this room, this is a very smaller area. So I can take my reference as a straight line because it does not affect much. I think, are you getting my point? Suppose for this point or for this level, if I want to measure the height of this point and the height of this point, so these 2 points are taken with the reference level of this because it is very short distance. So we can take a certain line as a reference or datum to measure the height of this point or the height of this point. But if our area of survey is very large, suppose 200 kilometers or 2000 kilometers to 1000 kilometers, suppose this can be the area of any country and we want to survey in the area. So how we will establish a datum or reference in such a particular area? So this is the question. Okay, now we will see how to establish that. Suppose for small distances we can take it as a straight line as a datum or a reference to measure the vertical height. But suppose if your area of survey is very large, so what will happen? So now see, for the big area, suppose we are dealing with a big area as I have mentioned. So this is, suppose this is the curvature of the earth, right, or this is the surface of the earth. Suppose we are dealing with a larger area. If we are taking a short area, suppose we are taking this area, so for this particular area we can take our reference or datum a straight line. But if we are dealing in a big area, suppose 2000 kilometer to 1000 kilometer, so now the curvature of earth play a role to define the datum or reference. Now it cannot be a straight line because due to the curvature of the earth. Suppose this is the curvature of the earth and you are starting from this point and moving to this point. Okay, suppose here in this point you have to take elevation of this point A and this is another point B. So you have to take also measure the elevation or height of this point B. So you cannot take the reference or datum on a straight line because as the distance increases, the curvature of earth plays a role. What role? For every 1 kilometer, listen it carefully, for every 1 kilometer, the tangents which is passing, suppose this is the tangent which is passing through the curvature of earth, start deviating toward the earth. Now how much it deviates? Let's see, it deviates by 8 centimeter. Now you are getting my point that if we are moving a 1 kilometer or if we are taking a 1 kilometer straight, that means in 1 kilometer our tangent start deviating toward the curvature of the earth by 8 centimeters. Okay, or if this distance is more than 1 kilometer, how will tangent deviates? If the distance is suppose 10 kilometers, so the tangent deviates, how much? 80 meters. Okay, this is the ratio of deviation of tangents toward the curvature of earth or due to the curvature of earth. So we cannot take a straight line for the larger area of survey as a datum or reference through which we can measure the height of particular point. So if we are taking, suppose we are taking the point B, and we are, for this point B, we are taking this line as datum. So this is the wrong. You cannot measure the elevation of this point with this reference point. Why? Because here your tangent is deviating through a certain amount, and that certain amount, if it is a distance of 1 kilometer, it deviates through 8 centimeter. So your straight line will somewhere here. So now we have to see how the curvature of earth define the datum or reference. Okay, now we will see it with another example, or we will see how this curvature of earth play a role to defining the vertical controls. Okay, now we are taking, or we are understanding it by some other example. Suppose this is the surface of earth. Okay, this is, I have taken the surface of earth, and I have picked a point here A, and we have taken the point here B. Now we want to see on which level the point A is and on which level the point B. Okay, so suppose if we are taking it as, suppose we are taking this straight line a datum, or a line passing through the surface of the earth, and we are considering this line as datum or reference. So what will happen if we want to measure the height of A and height of B? Suppose from this reference the height of B is, suppose, HB, and from this the height of A is HA. So what will be the result? As you can see from here, HA is smaller than HB, or you can say HA is below from HB, or the position of point B is higher to the position of point A. So what relation we will establish? That HA will be less than HB. Okay, so how we'll conclude this? Suppose if I drop a water droplet here at point V, so what will happen according to this relation? It will move through the point A. Why? Because we have already mentioned a relation that HA is less than HB. So water will move from higher point to the lower point. Okay, but now we will see, is this relation is practically valid, because we are talking about datum. The datum is a straight line. So if it is a straight line or a reference point, if I drop a water on this straight line, so water will neither move toward the left or neither move toward the right. Its tendency is to stay at a certain point if this is a reference or a datum or a straight line. But here it is not happening. If we are putting a water droplet on HB and we are mentioning that HB is higher than HA, so what result is that? So if we are putting a water droplet on HB, it is moving toward the HA. Okay, so now we will see how this will play an important role. Okay, so now we are moving to it as horizontal level, or we will see what is the effect of curvature of earth. Okay, now we are taking it as this relation HA is less than HB, but is it not so? Why is it not so? Suppose we have taken this as datum a reference line, but this reference line is considered, as I have already mentioned, for small distances, but here the distances are large. So what will happen? Suppose we have a curvature of earth like this. Okay, suppose the curvature of earth goes like this, and we have taken this line nearly parallel to the curvature of earth. Okay, this line is representing the curvature of the earth, and this second line which is passing through the point A and which is passing here also through the point B. So this line is nearly, I am saying nearly, equal to the curvature of the earth. So now let's see what happened. This line is passing through the point HA, and this point is also passing through this line is also passing through the point HB. So this line is known as equipotential line. That means the perpendicular on this line at every point is a tendency to move through the gravity of the earth. What does it mean? That means if we drop a perpendicular here, its tendency is to move through the gravity or toward the gravity at any point, if we are saying it as equipotential line. Okay, so now we will see this line is also passing through HA. So what will happen? At HA we will measure, or we are taking the reference, the curvature of earth. So this height is taken as HA, and now our reference level of HB is this height to the curvature of the earth. Okay, so now what we are seeing that the line passing through HA and HB will define the height of HA and HB, because this is the line of equipotential line, and its tendency that anywhere on this line the perpendicular moves, or the direction of perpendicular is always toward the gravity. Okay, so if we see that from this point the direction is toward the gravity, from this point the direction is also from the gravity, so the height of this point HA is here greater as compared to the HB. Now our relation is reversed. Why? Due to the curvature of the earth. That due to the curvature of earth, or due to the equipotential line which is nearly equal to the surface of earth. Suppose we have taken a equipotential line which is passing through first the point or from level HB, another equipotential line which is passing through the point A is mentioned here. So now from this relation we can see that HA will be higher to the HB, because our datum is the curvature of the earth, or the another line which is passing is known as equipotential line. Another line is also passing through HA, it is also equipotential line. So this line can be passed through different points on the surface of earth. So suppose our point is HA and our point is HB. Now you can see HA is higher than HB. Now what will happen if we drop a liquid of water on HA? It will neither move toward the left or neither move toward the right. It will have the tendency to move through the direction of gravity. Okay, same as here, it will not move like this and it will not move like this. It will try to move to the direction of gravity. Okay, so now our relation is says that HA for practical application is greater than HB. So what will happen from this? What we have concluded that the surface of Earth is known as geoid. What does it mean? It is known as geoid. इसको हम क्या बोलेंगे? इस सरफेस को हम क्या बोलेंगे? In which we have taken or we have measured the vertical heights of different point on the Earth's surface. So this curved surface is known as geoid as a reference. Okay, I think you have got the point. So for smaller area we can simply take it as a simple straight line, but for a larger area we cannot take a straight line due to the curvature of the Earth taken into account, right? So for that we had taken the surface geoid. Okay, next move on to the another term that is known as mean sea level. इसको हम बोलेंगे, we will call it as MSL, stand for mean sea level. So what is that? What is mean sea level? For every country there is some standard from which we are taking all the vertical heights. So for every country that standard is considered as mean sea level, or you can say that sea level. So for the period of 19 years, the level of sea water is observed, that how much it is. For suppose for the first 2 years the level is here, for another 2 years the level is up, and for another 5 years the level is down. So for the 19 years the level of sea water is observed, and by observing this level of sea water the average value is calculated, and then we will consider it as mean sea level, the average value of sea for a period of 19 years is considered as mean sea level, and this could be different for different countries. Alright, so we will taken as a reference for the entire country. पूरे country के लिए हम एक लेवल ले रहे हैं, रेफरेंस लेवल ले रहे हैं, through which we can measure our vertical controls or we can measure our vertical heights for the leveling purpose. So that level is known as mean sea level. Alright, next we will see what is local datum. Next point is termed as local datum. Okay, now we will move into 3. What is local datum? Local datum is considered as, for suppose you are working in a field and you have to measure the height. Suppose you are working in this particular area, okay, and there are some points which have been established with the help of mean sea level, taken reference at mean sea level. That means ये हमने points establish किए हैं, we have established this point or we have taken the elevation of this point with the help of a mean sea level. We have measured the height of this point from mean sea level, but it is very uneconomical, you can say, or it is very difficult to take a reading from mean sea level for a short survey area. Suppose this area of survey is very big, so we have already established 2 points. Now in this surface we are taking as, suppose it is area of 1 kilometer by 1 kilometer, my area of survey is this, and now I want to establish a datum with respect to these 2 points. So that datum will refer to as local datum. Okay, so if we are establishing any reference line in a particular area with respect to or taking reference these points, so that datum is termed as local datum. Local datum means we have established for a short duration or for only a small area of survey, so that is known as local datum. Now move on to the another term, that is known as benchmark. So what is benchmark? Okay, next is benchmark. So benchmark is known as fixing the point accurately with respect or with taking a reference from the mean sea level. For example, very good example of benchmark is, as you have seen, the railway station have mentioned their point with respect to the mean sea level. If you observe the railway station, suppose for example if you are any city, you can see and watch where the name of the city is mentioned, below that there is a tag of MSL. It will represent the mean sea level. For example, it is saying that it is 200 meters, or you can say 200 units. Okay, what does it mean? It is 200 units away from the mean sea level, and the vertical control of this particular city is taken as the reference mean sea level. So moving on to our points, that suppose we are going to fix the level of these 2 points accurately. So we are taking the reference as mean sea level, and we are fixing the height of, somehow we are fixing the height of these points. So that point is known as benchmark. Okay, and these points are mentioned very accurately with respect to the mean sea level, because we cannot take again and again the reading from, suppose we are working in a very small area, 1 by 1 area, 1 kilometer by 1 kilometer area, and we are referring or we are taking our datum, or considering our datum with respect to a mean sea level, because mean sea level is established for the entire country. So we have to know some points which refer और which has been taken with the help of mean sea level. यानी कि mean sea level से अगर हमने इस point को mention किया है, we have mentioned the height of this point correctly. So if we have the height of these 2 points, so with the help of these 2 points we can mention or we can establish a new local points or temporary points with the help of these 2 points. So benchmark is of 2 types. First is known as permanent benchmark, and second is known as temporary benchmark. So what is permanent and what is temporary benchmark? Permanent benchmark are those benchmarks on which these points, suppose this point is A and this point is B, is fixed accurately with respect to the mean sea level. So these points are known as permanent benchmark. Now with respect to these 2 points, for our survey area, we are taking help of these 2 points to establish another benchmark, another local benchmark for our area of survey. Suppose we have mentioned a point C with respect to the benchmark A. So this benchmark C is referred to as temporary benchmark because it is taken with reference to the permanent benchmark. Why it is taken as? For completing a small area of survey or for completing the work of a small area for surveying, we have established a new point or new benchmark with respect to the permanent benchmark, whose height is accurately being measured with respect to the mean sea level. We are not referring again and again for short work a reference mean sea level. That's why we are establishing the benchmark, and these benchmarks are established throughout the country. A permanent benchmark are established throughout the country with respect to the mean sea level. Okay, so next topic of our discussion is that is known as RL. What is RL? Now we've moved to RL. Next, after studying RL, these points we will discuss in the next lecture. What is RL? What is term leveling? What is level line? What is level surface? We will see through the next lecture these points: RL, leveling, level line, level surface, and the principle of important is principle of leveling. Then some levels, we will see what is levels. So these are our points which we will discussed, or which we will going through the next lecture. Okay, we will see in next lecture what is RL, what is leveling, level line, level surface, horizontal line, horizontal surface, what is the principle of leveling, and what is our levels. So we will understand in these points in next lecture. I hope you will understand the topic of today's lecture, or the basic of today's lecture of civil engineering related to the point or related to the subject surveying. Okay, so if you are understanding these points, it is very easy to understand the concept of leveling. All right, we are not moving directly to the leveling or leveling instrument. We are first seeing some basic of leveling. Right, so I am closing down today's lecture, and we will see you in the next lecture. By this note, just if you like my lecture, share it, like it, and comment down to the video. It will help and it will encourage me to make more videos for you. All right, so by this note, until then, eat well, sleep well, and take very good care of yourself. Thanks for watching. Thank you.